So guys, today I'm going to talk about Kotlin collections. So whenever we are choosing a language, right? So there's some languages where we are not given a choice, something like JavaScript or something like Java. Those are basic languages which we have to use in some of the projects. But a lot of time we have choice, right? Something like when we have choice of working on some other higher level languages, which increases our speed. So Kotlin is one of those higher level JVM languages, which reduce the amount of code that we have to write, and also which provides a lot of additional functionalities, which again like help us in moving faster. So I've previously worked with Scala and Clojure, and so they both are like really good languages. Like one is type safe and other is like Lisp language. So both of them has their pros and cons. So this video is not in any way to compare Kotlin versus Scala versus Clojure. So I think they all have different pros and different cons. So this video is just about talking about what Kotlin collections provide. Uh, but like whenever we are working on any of the functional languages, a lot of functional languages would provide immutable data structures. When we talk about immutable data structures, we mean is whenever you're trying to modify a list, so a new reference of the list would be created and the old reference would be unchanged. So Kotlin, it doesn't have that type of immutability, but it does prevent us from modifying mutable collections and all. And that's the first feature of Kotlin, which I like. So if we see here, so here we see two type of interfaces for list. One is the normal list interface, right? Another is like the mutable interface. So the list interface just has read-only methods. It does not have any modifier method. Whereas the mutable list, it has methods like update, delete, update, remove, or add. So this separates out the concerns. If you're returning just a list to our client, like to the client of the function, in that case, he'll not be able to modify it, right? And and in case we are returning a mutable list, it means that okay, we like it's already understood that maybe it's safe to return that. So in most of the code, we would always be using list. So just to prevent us from any mutability bugs and all. So yeah, so this is a good feature. So the second feature which I liked about Kotlin collections is it provides very nice constructor functions. So if you see here, we could easily create a mutable list where of integers by calling mutable list and just passing in the integers now. Similarly, we can create a read-only set very easily by passing like just the numbers and creating a read-only set out of it. And same for map. So a lot of time we'll be writing the test code and all. So these constructor functions help reduce the amount of code that we use. In Java, to do the same thing, to create a map of like 10 entries, uh, it would take 10 lines of code, but here it would just take one line of code. So yeah, so the code becomes very, very concise now. The next is creating a copy of the collections. As I explained earlier, Kotlin does not provide a fully immutable data structures, but it provides one way to prevent like mutable data is by separating out the interfaces. The second is to return a copy of the collection that you update and all. So that could be easily done by calling toList or toMutableList, toSet, etc. or any of these two functions. It would create a shallow copy, right? By shallow copy, what I mean is all the references of the list are copied, but the data, like the actual data, is not copied. So if you modify the data, it would be copied. It would be changed in the newer variable also. But like if you add an element to the previous list, the copy would not have the new element because the copy is a shell copy of all the references. Other very like useful feature is ranges and progressions. So I was working in a project earlier where we had to show like nodes in a network, and sometimes we had like a fixed number of nodes and all, and we had to iterate over it. So like these ranges and all provided very easy way for us to iterate over them. So using if operation, you can check like whether if something is within that range or not. By calling for, you could iterate over that range and like print all the variables and all. So you could just also provide a step, which is like you can provide the progression that what should be that what's the step you want to take. You could also provide your own custom ranges. So to provide your own custom ranges, what you have to do is you have to create an operator function range too within your class, right? So once you've done that, just like we do one dot four, which creates a range from 1 to 4, you could create like version one dot to version two. So it's going to return all the versions within those two. So the logic for determining like what all versions you want to return is like here, you just decide like what all versions you want to return between those two versions. So in this case, I'm just returning all the major versions. Like here, the version has major and minor. So in this case, I'm just returning all the major versions that fall between that range. Right. So it's again very useful, and you can create your own custom ranges and all. Next is sequences, lazy sequences. So this is a bit advanced topic, but it is like really very useful. Suppose we have 1,000 elements, right? And then we are transforming each of those 1,000 elements, and each transformation takes 2 seconds. Now the amount of time that is needed to transform all of the elements is 2 into 1,000, which is 2,000. So, and suppose you have to return this transform list to the client, to the client, whoever is calling your function, and the client might just need to access 10 elements, right? So the 10 elements could have been transformed in just 20 seconds, but we had to go through the entire list because we were doing eager evaluations, like eager transformations, and we transform each and every element, even if the client had to just fetch 10 elements. So sometimes we really don't know that how many number of elements the client would be accessing, right? But at the same time, we don't want to apply these heavy operations eagerly. So what we do is we just like we do the mappings, right? We do the transformation and all, but the code is not evaluated until unless client is accessing it. So if suppose like the client access first 5 elements, it's going to see, okay, this is the first element. It's going to pull that out. It's going to apply a transformation on that. Then it's going to pull the second one. It's going to apply transformation on that till the fifth element, right? Or if you do 10, it's going to do one by one and it's going to apply transformations on those 10 elements. So instead of 2000 seconds, you now just spend like 20 seconds in case you're just using the 10 elements. So this like increases the performance a lot in case you're not using the full list and all, right? It's a very useful feature, and there's other languages like Clojure and all. I think by default they use pretty much like all the operations are lazily evaluated. But there's sometimes like if you're working with a smaller lists or smaller collection and all, like suppose with 2 or 3 elements, so there is some overhead involved for creating like lazy sequences and all. So maybe in those cases, it is fine to work on eager ones. But if they're longer lists and all, better you could choose like lazy sequences and all. Also, you could create infinite sequences using a, a a sequence. It is difficult to first like realize what is the concept of infinite sequence. So, but since they are lazily evaluated, like we are not creating the full sequence, right? We're just creating the blueprint of the how the sequence should be created. And as we access like first elements, it uses that blueprint to fetch all of those first 5 elements. It's going to be 1, 3, 5, 7, 9, and so on. So yield and yield all could also be used to provide like add means like sometimes like maybe the list that you want to get, like the sequence which you want to create does not follow a particular order, right? It does not mean like suppose the elements which you have first, third, fifth element are very different elements, right? And after that they follow a particular order or something. Or maybe first 20 elements are follow a particular order, next 20 follow a different order, like a different arrangement and all. So those could be achieved by calling yield or yield all. So in this case, when you're fetching the five elements out of the sequence. So the first element is created by yield. It would return the first one. Yield all, we can pass iterator or a sequence also, or a collection also. So in this case, our collection has two elements. So yield all would be called on three. So like 3 and 5. So the second element would be 3. The third element would be 5. And yield all is called on an infinite sequence now, right? So after the third element, the fourth element, when we try to get it, it would be 7, and the fifth element would be 9. If you want to get one more element, that one more element would be 11, and so on. So yield and yield all provide us a lot of flexibility in creating like these different type of sequences, which you're normally not able to create. And the sixth is collection operations. Uh, this is like for sure the most important feature. And when I went through all of these collection operations, like it brought a huge smile on my face, because these are type of things that you'll always look for in any language. So uh, the documentation also covers them nicely. So we'll quickly follow documentation and see what all does it provide. So here we see all the common operations that are provided by Kotlin. So the first we see is transformation operations, where we could map over a list of collection, and it would transform each element. Right here it says transforming each element by multiplying by 3, but you could provide whatever logic you want. It's going to transform each element of that list. You could zip two different collections, right? So here you could zip like red with fox, brown bear, gray wolf, right? And then if you want to zip two lists of different elements, the smaller one would be taken. Right? So here, like in this case, it just says red fox and brown bear. It doesn't include the third one. You could also create like maps very easily by using associations. So here we have a list, and you can call like numbers.assoc with uh, it.length. So it's going to create a map of like the length of elements, and then yeah, it's going to create the keys are the elements and the values are the actual length. So this could be very handy when we have to create like smarter maps and all. So we don't have to write a lot of logic using this. Flattening I've not used this too much. Right? Like this might be useful in some cases, might not be. And string representation, again, like we use it all the time. Right? So again, like it provides various options and all for string representation of the collections. The next type of operations is filtering. So this is also included in Java these days, like mapping and filtering both. So here you could do other things also, like you could do filter not or something like that. For each, I think it's also included in Java. So yeah, so these are pretty much included in every language these days. Partitioning is very like it's also useful. You might not be using every day, like based on the type of project you're working on, but uh, I do use it oftentimes. And these to test whether there is a single element like that matches the criteria or not. Any is there, none means there's no element, all means that all of the elements match the past predicate. So those are filtering operations. Plus and minus are operations which allow easily addition or removal of the elements from the list. So we create a list of elements here. So you could say plus list, right, which has the fifth element, and the minus list removes it. So no need to write like delete or remove and all. These are like operators which are very concise. Group by is useful when we like a lot of time we want to group the strings and all by their length, right? Or it could be we want to group the elements by the special type and all. So it provides group by. I don't think so Java provides it, like the group by operator and all. This is used a lot in everyday programming. This is fine. Like take and drop are again like nice functions, especially when you're working on sequences and all. You just say that how many you want to take and all, or you want to drop last or something like that. Uh, Ordering is again like it's already part of Java, and like similar concepts are used here. You could say sort by or sort well and pass like either a comparator, or you could do the natural sort, which is when you provide the comparator. So aggregate functions again like it provides max, min, max, average, or sum, count. These are also very useful. One of the very useful things which we use every day is like how do you fold and reduce in this. Suppose you have a list of like X elements and you want to get like a single result or a result that is not of the same size as X, right? So you want to transform it, but you want to reduce the elements to a specific number. So fold and reduce are used a lot for them. So if you're working on a data project, like you will be using very often. So and also it's good to practice this fold and reduce both because it enhances our skills a lot, like while working with the data. So this is like the normal like removal or updating of the elements and all. It's a normal function related to it. And here it specifies the normal list functions or set functions or map operation and all. But the first, like we see transformation, filtering, plus, minus, grouping, and retrieving collection parts and all. So on the aggregate functions, right? So these are really very nice enhancements that have been provided by Kotlin, which definitely reduced the amount uh, amount of code that you write. I was really very happy after seeing this because this is the type of things which I feel like a higher order language or any language should provide. It's a good language again, like it's not fully immutable, but provides a lot of like it prevents us from like writing code which produces mutability bugs by separating out of certain concerns, like separating out read-only collections from read-write collections, and also providing us a easy way of creating the copies and all. So that's it. In my further videos, I'm going to talk about other features of Kotlin, but today it is just for collections. Thank you.